In this module, we finally reach the visual or striate cortex, or the occipital cortex, depending on who you talk to. And that's this area right here at the back of our brains. So light that gets captured by the retina travels down the optic nerve to the lateral geniculate nucleus. Once it's processed there, then it travels down to our visual cortices. And the first stop on that pathway is V1. And here it says it catalogs input. It transfers that to V2, and V2 kind of serves as a junction point. V2 starts to separate out these two pathways physically. So V2 projects onto V3, and it projects onto V4. So color and form alone, and then motion as well. So if we look at a schematic representation, here we've got the projection from the retina onto the lateral geniculate nucleus, projection from the lateral geniculate nucleus into V1 here. V1's primary projection is into V2. V2 then projects into V3 and V4, and V3 projects into V5. And the pathway here that goes down, including this small bit here, that's the ventral stream. That's the parvocellular pathway, object recognition, color, fine detail. The path that goes up this direction, that's the magnocellular pathway, the dorsal stream, the how-where pathway. And if we want to see exactly how those projections go, let's look at the relationship between area V1, V2, and V4. So remember, lateral geniculate nucleus comes into V1, V1 then projects onto V2, V2 then projects onto V4. And let's do it by locating specific cells' visual field. So if we were to say hit this cell here, cell 1, and it was right there close to the fovea, then we'd find that the representation is pretty high resolution. So that cell represents a really pretty small area of our visual field. But as we move out along V1, we find the resolution increases as we move away from our fovea. So that by the time we get to areas on the outer edges of the retina, the resolution is significantly lower. Okay? So resolution for the fovea very high in V1. As you move away from the fovea, the resolution decreases significantly. What next? Well, V1, those cells, they project onto V2. And so when we look at V2, and we look at the receptive field for a cell in V2, what we find is that cells from that edge of the retina with high resolution project onto cells at the edge of the retina with low resolution in V2. And it goes basically in reverse order all the way back to area 8 here, which has high resolution that is close to the fovea. Notice the resolution for these, though, is greater than the resolution for V1. Finally, when we look at projections onto V4, we see that pattern repeat itself again. All right? So high resolution to high area, low resolution to low area, high resolution to high resolution area in V4, and we start to see the emergence of a lot more specific feature extraction cells as we start to travel that pathway in V1. So in cortical cells, in the visual cortex, we find a number of different kinds of cells. we have simple cortical cells. They have excitatory and inhibitory fields arranged side by side. The effect of this arrangement is to make these cells show a preference for stationary bars of a particular orientation. They also fire strongest for longer bars. Simple cells are more sensitive to direction, some to binocular disparity. And so they're starting to extract bars, orientations, sometimes direction, sometimes binocular disparity.